Yes, welcome to Business Plus channel. My name is Wow Chemist, and today we are going to talk about detergents. We are still in organic chemistry. We are pushing the organic chemistry, and it is getting interesting. So let's talk about detergents today and see what are detergents. Then we shall see their classification. After that, we shall be in position to classify them and talk about them one by one. And we shall see how we can also prepare the soap detergents. Then after that, we shall be in position to see the equations or the manufacture of soap and those chemical equations which are involved. Then after that, we shall continue and go to soapless detergents and into them, how we can get to understand them and how we can also try to manufacture them. So this is the applied chemistry we talked about in senior one when they were classifying uh, the different types of, form of chemistry or the branches. So here we have detergents and we are saying they are just cleaning agents. We have used them at home several times. Example is the soap we are using. And then also we have Omo. Those are what we call the detergents. But then we are saying they are classified into mainly. We have the soapy and we have the soapless. And if you don't want to call them soapless, you can say synthetic detergents. So for soapless detergents, we are mainly going to look at soap. And we are saying soap itself is a mixture of salts. So today you have to know that the soap you're using for washing your clothes is a mixture of salts of medium chain and long chain carboxylic acids. So it is of medium chain or long chain carboxylic acids. And the example given is that you have alkanoic acids that we talked about them in previous lesson. When you combine them with sodium hydroxide, which is the base, we shall be in position to get the salt and water. So therefore, salt is a mixture of, salt is a mixture of salts of medium chains and long chain carboxylic acids. And we have seen the equations where we say R represent what we call the alkyl group. AG, we have CH3, CH2. These are the hydrocarbon parts of it. So this is the equations given by this. This is R and we're showing the functional group. We have been following here. We are showing the functional group for carboxylic acids. Then we combine the sodium hydroxide, which is the base. We shall be in position to get that salt, which is the soap itself. We shall be in position to get this compound with water. So we can also get, or we can react what we call octadecanoic acid with sodium hydroxide, and we shall be in position to get octadecanoic. So after getting this compound, we shall now say that is a soap that we have formed. So here when we say octadecanoic acid, we shall be in position to see that this one is having how many carbon atoms? We have, there are very many. You can calculate them from here and you get the number of carbon atoms which are in this. Then after us finishing this, we shall be in position to look at the manufacture of soap. How can you manufacture a soap? And the process is simply called saponification. So saponification is the process by which soap is manufactured. And we have the procedures for manufacturing soap. And we say it, in these procedures, you get the oil, or if you want to get the oil, you can get what we call the fat. And this one is the vegetable fats or oils is mixed with concentrated sodium hydroxide, a strong base, and then after that you boil the mixture until frothing is stopped. So after that you'll now add what we call concentrated sodium chloride. So sodium chloride here, the concentrated one is what we call the brine. So after us adding this one, we shall now be in position to allow this mixture itself to cool down. Then you filter, is then filtered, of course, and then purified. Then you can add dyes and perfumes. That's why sometimes you see different shops have different kind of smells. So you have dyes, perfumes will be added to improve its quality. And then from that, after you describing this, you'll be in position also to come up with equations. As a chemist, you'll be in position to come up with equations and you know what exactly is taking place in the mixture, what is being formed. So here, let's say we are going chemical equations. So let's say when it is oil, let's say we are using the vegetable oil, not fat in this time, you will be in position to get, let's say we have CH2, CH, CH2, and here we have attached to oxygen, is also attached to oxygen, attached to oxygen. This is the long chain carboxylic acid. So, and then from there, we shall have attached to this, and this one also is attached to this carbon atom, also attached to this carbon atom. So after us having something of that kind, so say here we have 17, then if it is fat, we shall have 33 hydrogen atoms here. Also here we shall have 17, is 33, and here we shall have 17, is 33. Now this is the long chain we talked about. Long chains carboxylic acids, you can see the functional group. You'll be in position to see that. But we are saying, after getting this long chain carboxylic acid, which is now the vegetable oils, we shall be in position to mix it with concentrated sodium hydroxide. So here I can say it plus concentrated sodium hydroxide aqueous. So we are following our procedures. We are now here. Then after that, we shall be in position to boil this mixture. So we shall boil the mixture. After boiling the mixture, what shall we get? So in the solution now you had your sodium, concentrated sodium chloride, which is brine. So here we shall be in position to get something of this kind, CH, means C17H33, CO. So here let's show these charges. This is aqueous being formed with CH2, CH, CH2, OH, OH, OH. Now, this is what we call the soap that we have been looking for. And we say it's the salt of long chains or the medium chains carboxylic acid. And this one, chemically, we call it propane. Propane 1, 2, 3, triol. Or the industrial name is what we call the glycerol. So I put it like that. And this is the soap we have been looking for. Now, what if I'm not using this and I said at this time now we are going to use fat? So when it is fat, what are we going to get? So the only difference is that this one will change to 35, and then for oil it is 33. So it shall be in position to have. So here in our mind, we know that carbon is taking 4 bonds, and when you go through it, you'll be in position to see carbon with 4 bonds, oxygen with 4 bonds, and at the same time, hydrogen with single bonds. And then here we shall have something of this kind. Shall have something of this kind. There should be space. So here we shall have 17. Here we shall have 35. Here we shall have 17. Then is 35. 17 is 35. So you're just as following the same procedure. So we shall be in position to add concentrated sodium hydroxide. So let's say plus concentrated sodium hydroxide, which is aqueous. Then we boil this. Then in the process, we also add sodium chloride, concentrated sodium chloride, which is called brine. We're in position to add it. And after that, we shall get our soap that we are looking for. So these charges. So this is soap, aqueous, being formed with glycerol, CH2, OH, CH, OH, CH2, OH. So this one here is what we call the glycerol. 1, 2, 3, try all. So these are the equation that if you're given in exams and they say describe how soap is manufactured from vegetable oils and they are specific, you'll be in position to write this equation. If they say it's from fat, you'll be in position to come up with this equation. So it is very simple like that.